Math-sayang araw sa ating lahat. I am Gemma Zamboy, a grade 8 mathematics teacher and your moderator of the day for Bonifacio Javier National High School. Kanina po, sinamahan ng grade 9 learners and home learning partners si Ma'am Alaysa sa kanyang lecture. Bago po tayo magsimula, huwag nating kalimutan i-follow our official Facebook page, Math Team Mathematics Teachers Association of Mandaluyong. Don't forget to like, share, subscribe sa ating YouTube channel, and click the notification bell para updated kayo sa ating upcoming video lesson. Mga batang mandunong at home learning partners, sabay-sabay tayong mag-aral at matuto sa advanced learning lessons for week 2 of 3rd quarter. At ngayon po, ipinakikilala ko po sa inyo ang susunod nating lecturer ng grade 10 mathematics na si Mrs. Elva S. Tutaan. She's currently teaching at Bonifacio Javier National High School, a mathematically gifted and very artistic person. Batang mandunong and home learning partners, samahan po natin si Ma'am Elva sa kanyang lecture.
Pleasant afternoon, dear students and home learning partners. I am Teacher ELVA, Bonifacio Javier National High School, and I will be your guide for today's online academic review of Mathematics 10 CLAID Learning Module for Week 2 of Quarter 3. Are you ready to learn? Let's start! Our lesson competency: the learners solve problems involving permutation. Our lesson objectives are: the learners find the number of permutation of distinguishable objects, find the numbers of arrangements of n objects in a circular permutations, and solve problems involving permutations. How do you understand the word distinguishable? Yes, distinguishable means clear enough to be recognized or identified as different. Permutation, as we learned from our lesson last week, is an ordered arrangement of objects. So that means distinguishable permutation is an ordered arrangement of objects that is different from one another. Let us analyze this problem. How many possible three-letter arrangements are there in the word mom? Using the permutation, we have permutation of 3 taken 3 is equal to 3 factorial, which is equal to 3 times 2 times 1, and that will give us 6 arrangements. By 3 diagram, our options for the first letter will be M, O, and M. Since the first letter M is already placed on the first letter position, the remaining 2 letters will be our options for the second letter. And so for O and M. Then we will have the last remaining letter to be placed on the third letter. How many ways the letters be arranged in each outcome? As shown in the diagram, there are 6 arrangements. 1, 2, 3, 4, 5, and 6. What did you observe about the 3-letter arrangements? Yes, there are 2 MOM. There are also 2 MMO and 2 OMM. We know that the permutations of 3 letters of the word mom are 3 factorial. We must take into consideration that we cannot distinguish between the 2 M's in any permutation, but the 2 M's can be permuted in 2 ways and do not produce a different result. Hence, the number of distinguishable permutation P is given by P is equal to 3 factorial divided by 2 factorial, and that is equal to 3 times 2 factorial divided by 2 factorial, and that will give us 3 arrangements. Therefore, in dealing with permutation, with repetition, or distinguishable permutations, the number of permutations of n things where A things are alike, B things are alike, and C things are alike, and so forth is P is equal to n factorial divided by the product of A factorial times B factorial times C factorial, and so on and so forth. Let us now use the formula to solve some problems. Problem number 1. Find the number of distinguishable permutations of the letters from the word basketball. The word basketball has 10 letters. Therefore, our n will be equal to 10, B is equal to 2, A is equal to 2, S is 1, K is 1, E is 1, T is 1, and L is equal to 2. And then we will substitute the values to our formula. Remember, if we deal with permutations with repetition, the formula to be used is P is equal to n factorial divided by the product of A factorial times B factorial times C factorial, and so on and so forth. So we will have now P is equal to 10 factorial divided by 2 factorial times 2 factorial times 2 factorial. We don't need to put 1 factorial, 1 factorial, 1 factorial, and 1 factorial because we know 1 factorial will be equal to 1. So to shorten the solution, we will have this format. Okay, and then we will have 10 factorial is equal to 3,628,800. So you may use your calculator to simplify or to get the value of 10 factorial. And then 2 factorial times 2 factorial times 2 factorial is equal to 8. And then the quotient is 453,600 ways. You may verify your answer using the calculator. So that's it. So we have 453,600 ways to arrange the letters of the word basketball. Problem number 2. I have 6 face masks and 4 face shields which will be given to 10 frontliners. In how many ways can I distribute these 10 gifts to the 10 frontliners? In this problem, we have a total of 10 objects. So our n will be equal to 10. Then we have 2 sets of the same objects. So we will have face mask is equal to 6 and face shield is equal to 4. And then we are going to substitute these values to our formula. Remember, our formula is n factorial divided by a factorial times b factorial times c factorial. Okay? So we will have P is equal to 10 factorial divided by the product of 6 factorial times 4 factorial. In this case, we will use the expanded form of the factorial, and then we will use cancellation. So the next step will be 10 factorial will be expanded up to 6 factorial because we will cancel 6 factorial in the numerator and the denominator, and then we will expand 4 factorial so we can also cancel common factors. So we will cancel that, and then another canceling of common factors, and then yan. So ang naiwan na lang ay 10, 3, and 7. So we will multiply all the remaining factors. So we have 10 times 3 times 7. And then the denominators, wala naman na, naiwan ay 1. So therefore, the answer is 210 ways to distribute 10 gifts to the 10 frontliners. Again, you can verify if your answer is correct using your calculator. So we have a reminder to use the correct grouping symbol when you use your calculator. Okay? Problem number 3. A frontliner at the Pasig City General Hospital has 4 blue PPEs, 3 white PPEs, and 2 green PPEs. In how many ways can he arrange all his PPEs in his locker? So in this problem, we have a total of 9 PPEs. So our N is equal to 9. And then we have 3 sets of the same color of PPEs. So we have blue is equal to 4, and then white is equal to 3, and then G for green is equal to 2. And then again, we will follow the same procedure, substitute the values to our formula, and then we will have P is equal to 9 factorial rather. 9 factorial divided by 4 factorial times 3 factorial times 2 factorial. And then we will use cancellation to shorten the process. So we will expand 9 factorial up to 4 factorial to cancel 4 factorial in the denominator, and then expand 3 factorial and 2 factorial to cancel common factors. And then that 4 factorial will be cancelled, and then that pair of numbers, and then also that pair of numbers. So we will have P is equal to 9 times 4 times 7 times 5. So we will have 1,260 ways the frontliner can arrange all his PPEs in his locker. Again, you can verify whether you get the correct answer using your calculator. Just make sure to follow the correct grouping symbols. Okay? Let's proceed now to our second topic, circular permutation. Circular permutation is an ordered arrangement of objects in a circular manner. Example of this is the group of persons seated on a round table, and the horses on a merry-go-round, and the beads of a bracelet. Let us analyze this problem. In how many ways can 3 people, A, B, and C be seated around a circular table. If we are going to arrange the three people, A, B, and C, in a line, the linear permutation will be permutation of 3 taken 3 is equal to 3 factorial. And that will give us 6 ways. The linear seating arrangement will be first ABC, second arrangement B possibly ACB, third is BAC, fourth is BCA, fifth is CAB, and the last possible way or arrangement is CBA. However, persons A, B, and C are to be seated around a circular table. If we will arrange A, B, and C around the circular table as shown in this illustration, notice that the arrangement does not even change if each person moves his position from one place to another. In this particular movement, clockwise movement, C is always on the right of A and B is always on the left side of A. In counterclockwise movement, C is still on the right side of A and B is still on the left side of A. The position of the persons still do not change. Hence, it represents one permutation. There is no starting point in the arrangement of things in circular pattern. So, when each person moves his position by one place clockwise or counterclockwise, the position will not be changed. Hence, if we have n elements, the number of linear permutations of n elements taken at a time is n factorial. Observe that n linear permutations correspond to one circular permutation. And this can be denoted as P is equal to n factorial divided by n. And that will give us the factorial of the difference of n minus 1. Now, if we use the formula, we will get the total number of circular permutations of 3 persons taken all at a time as the factorial of 3 minus 1. And that will give us 2 factorial. Therefore, there will be 2 possible ways the 3 persons be seated around the circular table. What if we will consider the direction of the arrangement in clockwise or in the counterclockwise rotation? Observe the arrangement of different beads in a bracelet, keys on the key rings, and the like. The clockwise and the counterclockwise orders are not distinguishable. Therefore, the number or the total number of circular permutations of n elements taken all together is P is equal to the factorial of n minus 1 divided by 2. But if bracelets, key rings, and the likes have locks, then the permutation becomes linear and can be denoted as P is equal to n factorial divided by 2. So we have to keep in mind these important points about circular permutation. 1. If the clockwise and the counterclockwise orders can be distinguished, then the total number of circular permutations of n elements taken all together is P is equal to the factorial of n minus 1. Number 2, if the clockwise and the counterclockwise orders cannot be distinguished, then the total number of circular permutations of n elements taken all together is, without luck, P is equal to the factorial of n minus 1 all over 2. With luck, we have P is equal to n factorial divided by 2. Let us solve some problems involving circular permutation. Problem number 1. In how many ways can 6 people be seated at a round table? So in this problem, our n is 6 and the clockwise and the counterclockwise orders of people in the problem can be distinguished. Therefore, we will use the formula P is equal to the factorial of n minus 1. So we will have P is equal to the factorial of 6 minus 1, and that will give us 5 factorial. And we know that 5 factorial is equal to 120. Therefore, there are 120 ways the 6 people be seated around a circular table. Problem number 2. In how many ways can 5 different beads be arranged if A. A bracelet has no lock, and B. A bracelet has a lock? So for letter A, our n is 5, and since the arrangement of the beads, the counterclockwise and the clockwise orders of the arrangement of the beads cannot be distinguished, we will have this formula. P is equal to n minus 1 factorial divided by 2. Then we will have the factorial of 5 minus 1 divided by 2. And then we will have 4 factorial divided by 2. And that will give us 12. Therefore, there will be 12 ways the 5 different beads can be arranged if the bracelet has no lock. For letter B, our n is 5. The clockwise and the counterclockwise orders of the bead cannot be distinguished, but the bracelet has a lock. Therefore, we will use the formula P is equal to n factorial divided by 2. Then we will have 5 factorial divided by 2, and that will give us 60 ways. Therefore, there are 60 ways the 5 different beads can be arranged if the bracelet has a lock. I hope you have learned and grasped our lesson so you will be able to do your individual activities confidently. If you have questions or clarifications, you may type your queries in the comment section below. Again, this is Teacher ELVA, Estutaan of Bonifacio Javier National High School, saying, never stop learning because life never stops teaching. Thank you for watching. Happy learning, everyone.